Oh, hey! Welcome to the stream, everybody. It's nice to see you. I'm Alexander Pascal, your Unreal Engine Community Manager, and joining me today is Francois Antoine. And we're going to be talking about some McLaren stuff, but first, Francois has some stuff he wants to talk about.
Yeah, hi guys. So, big announce. Obviously, 4.12 came out yesterday. And what's special about this is that all the enterprise features we've been working on over the past year made it into this release. So I know a lot of enterprise customers have been waiting for these high-end features to be available to them. And before, we were in special branches, and so we got all the QA testing done. And they all made it to 4.12, so it was a big achievement on our end. And we're super proud of all those enterprise features being in there.
Yeah, it was exciting to get to just announce that we were going to be integrating stuff from these demos in the previous stream on the enterprise stream. So if you tuned in for the enterprise stream, then you probably already have a heads up on what this is about.
Yeah. So just a quick recap, we're going to have some three guys come on right after me. They're going to go into some of these high-end features that got into 4.12 and on how to use them and what exactly that they do. But let me give you just a quick recap of what's in the 4.12 build. So obviously the big one here is the higher precision mesh normals. So we're able to have just eliminate quantization. So that's a big step. And you'll find these in the release notes for 4.12.
Yeah, we're just looking through the release notes to talk about what's already out there.
Yeah, and there's a nice description of each of these. We enabled a custom cube map and reflection probe, which means now if you set up a reflection probe in your scene, you're not only using that environment as a reflection, you can also export that and paint over it or add anything and feed it back into a reflection cube probe. So it's pretty cool. It's artistic direction. You can kind of modify what your reflection should look like without having that geometry actually live in the world. So it's pretty cool. High precision G buffer. Now for reflections, that's super important. You want to get that nice, clean, crisp edge. And Zabir is going to go over that with you. It looks amazing. And then of course we have the much awaited for dual normal clearcoat shader. So that's what you use for carbon fiber and paint flakes, metallic paint. We used it through our 570S GDC demo. So Ryan wrote that and he's going to go over that stuff with you and how to use it. It's absolutely fantastic. So we're still working on a lot of enterprise features for the next releases, but I hope you can use these right away. And we have documentation, I believe, that's nearly done on most of these features. So that should go out really quickly on a training site.
Yep. And I'm sure that we'll probably have a training stream about it at some point too.
Yeah.
So how to use the new features. And I mean, this is going to be kind of like a training stream later on when we actually have Ryan and everybody come on and show you what all the new stuff does. So that'd be cool.
Awesome. So I think that's it for me. Really, just a big announce. We're super proud, super enthusiastic. Everybody put a lot of work into these features. And whether you're using them for enterprise or if you want to use them on high-end games or even low-end, they don't really cost that much more than not having those features. They do add a lot of visual quality and accuracy, so very exciting.
Awesome. Well, we're going to play a B-roll real fast, and then we're going to swap out everybody and get all of our guests on. So thank you so much for coming on.
All right, thanks, Alex.
And we're back. Hey everybody, we actually got everybody on here. Zabir, I believe your mic is now on. You can say hey real fast.
Hey, everybody.
All right, cool. Everybody's on. Excellent. So it's good to have everybody actually here on the stream. But first is the news. All right. So we're going to actually use the same page we were just on to say, yes, the 412 full release is now out and available. It is full of awesome new features. There is, let's see, the full VR editor, all the new McLaren Enterprise stuff, sequencer is in there. Go have fun. There's just so much to see in the new release. I'm not going to actually go through everything individually, but yeah, I love the recording stuff. But there we go. I wanted to show off a couple of these nice GIFs. These are pretty cool. I didn't actually realize it until Yannick said it earlier, but that is Tim Sweeney on the wanted poster. So didn't know he's actually a wanted criminal in this world. Just be aware. And super tiny little church and all that. It's cool. Yeah, but if you're paying attention, you probably noticed we went crazy with this the other day or yesterday and just started, telling everybody about it. So come check it out. Try 412. Have fun with it. Please report any bugs as usual. Yeah, and overall it's a lot of new shiny toys to play with. I really like all the new mobile stuff too, and that's all the mobile stuff that we've shown off in the past, and we talked about it being in previews. It's finally out, so there you go. All right. At PAX West, we're sponsoring the Indie Mega Booth. In previous streams, you've probably heard me talk about us doing this. We love to support Indie Mega Booths. In this case, though, if you want to be on this one, if you're planning on anything at PAX West, you want to go there, set up. Until tomorrow, you see down here, until tomorrow you can actually submit your game to us for it. So if you've got something you want to submit, come to the Indie Mega Booth blog post. Down here's a link to get you started, but you have to do it pretty quick because the deadline is tomorrow. All right. I'd like to throw a little shout out to Pool Nation VR. They're currently number 3 on Steam Top 10 bestsellers right now. It is a very fun, personally I'm calling it dive bar simulator because that's kind of what it is. You and your buddies have a VR dive bar experience. You go out to this, here you go. This is a good example. You and your friends playing pool, but you can go out and throw around the drink bottles. You can get behind the bar and start playing with the taps. It's really good. Just looks like a lot of fun. It's a multiplayer VR game made in Unreal, and number 3 on Steam right now. If you've got a Vive and you really want to try a good multiplayer experience in VR, this is a great start. So, and it's 15% off. I should mention that. It's currently 15% off. It's good. It's affordable. $16.99. Why not? Price of just a few beers at my local bar over here. All right, and we also kicked off the announcement post here for the June Game Jam. We will be announcing the theme on the June 16th stream. Oh, there we go. On the June 16th stream. It'll be a lot of fun. It's our monthly jam. We always have a good time with it. I think this one's probably gonna, maybe it'll be a summer theme. Maybe we'll go wild with it. You never know what the theme's gonna be, so it'll be pretty good. Also talking about maybe getting guest judges in the future, other strange things. It'll be interesting. Stay tuned for more updates about what's going on with this. Cool. All right, that's the news. I'm gonna put that away for a second and get up this other thing real fast. Okay, so before we hop back to the screen, I'm gonna go into the Answer Hub and tell y'all who the Answer Hub Karma earners are. Oh great, I got logged out. Right. So, while I'm doing this, I'd like to say thank you to everybody who does come out onto the Answer Hub and answers questions, interacts with each other, tries to get to the bottom of various issues. Everyone who comes out here and talks to the community and tries to help them out. You build up karma over time, and if you earn enough karma, you will end up on our high scoreboard. So if you are on the high scoreboard and in the top 3, you get a badge on the forums, and our badge winners this week are, I've always wondered if I'm supposed to pronounce this a certain way. So Noctmar. Anyway, I think it means nightmare. But Noctmar, top of the charts this week, 458 weekly karma. that is a lot. So good work. Just behind him with 455 karma is J Blaswu. Does that sound right? J Blaswu? I guess. J Blaswu, people like to have usernames that are difficult for me to pronounce, but excellent work. And Luos, you're number 3. Good job, buddy. So to all of you, you'll be getting a badge if you don't already have one. To everybody else, thank you so much for participating. We'll see you next week, though. Alrighty. I'm trying to use the wrong mouse to do stuff, of course. Shelly, I believe we have a video clip for Community Spotlight. So, on to Community Spotlight. Cool. This was sent over to me I have the details here. This was sent over to me to show off what Insar Akaya, I'm probably mispronouncing that, but Insar made this Houdini procedural set dressing plugin and wanted to show it off with a brief clip there. But there's this whole plugin. Basically what it allows you to do is place blocks into your kind of general world. Just run it real fast again since it's kind of short. But you basically place blocks into a world, and then you can have Houdini then go over and replace all your blocks with appropriately sized building meshes, whatever kind of procedural mesh you want. And then at that point, yeah, you've just kind of got a pretty quick city built up, and then you can re-import it back into the engine, and it's super, or actually you can just do it all in the engine. It's pretty super cool. If you've ever won one of the game jams, then you've already got the full Houdini indie license, which is really fun. I'm going to post this in chat. And also, links to these things that I'm talking about will be available on the YouTube archive, so you'll also be able to find them there. So, great work. And let's see, next up. All right, back to main screen. Sorry, I'm making Shelly jump all around today. So sorry. So, Katatis let me know that he has been working on his website to create a new course content management system, basically. So you can submit your courses to here. I'm seeing a lot of you guys are kind of making these profile pages, course pages, or other pages like that to help get you out there and help promote your stuff. This is a really good another way of doing that. And yeah, there's a few up now, but Ryan, who is Katatis, is still, I think, taking more. Matthew is also on here. He's probably also in chat. So, cool. Good work, guys. Cedric, Cedric has been working on a networking compendium here. It's a downloadable PDF. It is very good if you're trying to do anything with online multiplayer. If you're doing networking and you need help, 100+ pages PDF document of what to do, how to do it, and everything that you're going to need to know to get started. Let me go ahead and post that also. So, excellent work. Thank you so much for your contributions. If anybody else out there is doing similar work or is doing anything cool that they would like to show off, or has massive tutorials, I love getting really big tutorials to show off to people, then contact me. Send me a tweet, hit me up on the PMs on the forums. However you can get in contact with me, let me know you're doing something cool. I really want to show it off. So, excellent work to everybody, and thanks again for doing this big networking PDF. That's great. I'm going to hand this over to you now, so you can have at. So yeah, we had Francois on a minute ago to kind of give you a brief rundown of what we'll be talking about. But now we can actually dive into it. Ryan, Jeremy, Zabir, thank you so much, and let's see what you got.
Hey guys, my name's Ryan Brooks. I know you've seen me on here a couple times before. Bear with me 1 second as I load up some test content real quick.
Oh, do you want to put that on the screen?
Yeah, before I'm just trying to find the BizDev test map real quick.
All right.
We had a bit of a scramble getting all the things together today. So let me see.
All right. If you want to go ahead and jump over, we're just going to go ahead and load up the maps.
There we go.
There you go. Cool.
All right, so I'm going to go ahead and first talk about some of the rendering improvements we had to our clearcoat shading model. So one of the things that we added for 412 was a new option to clear coat shading model with you can specify a different normal map for the bottom substrate as well as for the top. And so that allows you to have something like this where you have a carbon fiber substrate that is reflective both on the top layer and the base layer. So you see if I add a new light here, it's going to show me the reflections of the carbon fiber weave as well as the clear coat on the top. And show you guys how to enable that, and as well as a couple settings for manipulation. So first of all, that's actually enabled by a project setting that you're going to go under project settings down to under rendering. And we'll be here a lot today showing you some of the new things that Zabir's added as well. But you'll notice here under materials, clear coat enable second normal. Once that's checked, you'll have to restart the editor, and that will give you the ability to place down in materials this clear coat bottom normal node. And that's actually a way to pass an input from the material into the deferred shading pipeline. And it was just done that way for ease of implementation, because of adding pins to this actual node turns out to be quite complicated. And so you'll notice that other models use the same method, like the new hair model uses a tangent input with the same second floating normal. But I'll go ahead and show you guys the impact of setting that. So here we have just a very basic normal map for a carbon fiber weave. This was actually made by rendering out cylinders that have been rotated in the editor. So nothing fancy. It was actually made with primitive meshes.
You just did all that in editor?
Yeah, so...
Oh, and you've done a stream in the past about how to render normals.
Exactly. So yeah. And then I've got here changing the intensity of that normal map. So you see if I set it to 1, it's completely flat. If I set it to 0, it's completely intense. So usually somewhere kind of halfway in between is what you want. And another trick that we use to make it look better is here we have a roughness map that kind of has some striations, you'll notice, that kind of go in the direction of the fiber. And when you use that with a roughness spread, meaning you take that value and you blend it between two different values, you get this nice, almost a fake of anisotropy, where you see if I set it to 0, that's basically saying that the carbon fiber weave is a mirror reflection, which isn't really realistic. And if I change them in lockstep, it's interesting, but it's also a little bit flat. Mm-hmm. So one way you can add a little bit more depth is by having a range in these two numbers. So here, just by having one number at 1, and maybe I'll back down the other number a little bit, but you can get a little bit of kind of that blurry, but also shows definition. So you see here, you get that kind of plus shape from anisotropy that is a bit like you'd see in photographs. And you can see that in the 412 release notes. You see a picture where we've actually compared the carbon fiber on a real McLaren P13 mirror to one that we generated in the engine, and they look pretty close. So that same method that we use here for the second normal map for the carbon fiber strand also works pretty well for metallic flakes, although you definitely want to supplement it with some roughness variation. I have a very basic test material set up here, although I'm going to actually show you guys the McLaren materials since it's a little bit hard to show this. But I don't know if you can see here where there's actually sparkles that are being generated around the light. Let me grab this light and actually move it around a little bit. And when we get close enough, you'll notice when I move the light, it's not liking me to move that when it's not in view. But you see the sparkles, there we go. They actually move with the light.
Ooh.
And so that's just by using a noisy normal map, and you see the same thing going on down here. So I'll jump into that material real quick. And it looks a lot like the other one, except it just has a noisy kind of flake material as a normal map. And these were actually also generated in the engine by just dropping little pyramids, since those look pretty similar to flakes, and rendering out the normals at the end. So you see here we have the same kind of setup where we have a intensity for the flakes, which that can be either on or off. And then also supplementing it with a little bit of roughness kind of helps the same way. So we use the same kind of mask as just a grayscale height map, and that just gives you a little bit of noise that you can use to help kind of punch things up. And you'll notice as I increase this, it really changes the spread. So with the roughness and doing that together, it creates a pretty convincing illusion that when the light moves, the sparkles kind of dance. But the roughness kind of is a little bit more reliable when it comes to things like temporal anti-aliasing. So we kind of ended up doing a little bit of both just so that we had kind of a more persistent image. I'm going to jump over really quick to the McLaren demo. We have a little test map with a bunch of paint samples. Mm-hmm. And so these were actually set up by Francois. McLaren set him, you know what, it's not working.
So your earpiece not.
Yeah, my earpiece is not working, so I'm not going to be able to hear Zabir.
Sorry,
so these were actually these are photos in the back. These were little paint swatches that McLaren had sent out. And they sent us a whole array. You can see pretty much every paint we can imagine. And then we tried to recreate those with our materials. And the nice thing about that is we could really see one-to-one and tweak and try to get as close a match as possible. Although the one thing to remember is that these samples were fairly small. They're about 4 inches long, whereas we're trying to set the scale for a big car, so you'll notice we're setting our sparkles to be smaller. But that same method is being used there, and it works pretty well for just getting a nice kind of big spread of light around the lights. So just a couple different ones. You'll notice that some of them are very sparkly, some of them are very very subdued.
How many different actual materials are we looking at here? Is it all just through parameters?
These are actually all the same material, just by changing parameters. I would load up the material here, but it was actually set up by Alan Willard to be able to transition between 2 different colors. In the demo, it actually wipe. So the material here looks a bit more complicated than it needs to, which is why I showed you guys that simplified version in the other build.
Yeah.
But we're going to be releasing soon a project that has all of these paints in one big cleaned up place, and we have someone who's working on that right now. So I'm not exactly sure when that goes out, but it should be pretty soon. But yeah, so to summarize, for the paints we used a combination of a slight normal map in the clear coat bottom layer to give motion with the lights and parallax, and then a bit of roughness as well. And those go well together because the roughness variation is more persistent with regards to temporal anti-aliasing. One thing we did find is that the normal flakes tended to get a little bit blurred in motion by anti-aliasing. In fact, right now real time isn't on, but you'll notice if I turn on real time, they kind of soften up quite a bit. Let me toggle that on and off again. So, and that's just because the anti-aliasing is doing its job of reducing those stray errant pixels which it sees as aliasing. So by using the roughness variation with them, it gives them some neighbors to kind of converge with and just kind of helps the overall look. So that's about it for that, and I guess next I could go in and show you guys the basic features that Zabir also added to improve the quality. Bear with me as I try to put this ear mic back in.
You want me to clip it on you so it doesn't
sure,
go crazy? It's super faint.
I can clip.
So Zabir, are you, can we hear you? I got my mic back on.
Yeah, you want to help, Shelly?
Yeah, hey.
Alright, so I've got a list of your features here, the high precision normals, the custom resolution for the cube maps, and the custom cube maps, and the G buffer encoding. So I guess we can just go through those one at a time. So one issue that we actually ran into on this demo for the first time was that our vertex normal precision wasn't actually very good. And the higher polygon that a mesh got, the worse it would look. And that was actually because it was storing the tangents in the vertex normals as 8-bit, which means you actually were limiting the amount of precision you could store on those verts. And it wouldn't create bands, but it would create kind of facets. So Zabir made a new function, or a new method of storing those normals to help improve that. So it should be under the static mesh build settings under use high precision tangents. So somewhere in here, it might already be set.
Oh, it's right above where you are now.
Oh.
Full, use full precision UVs.
No, that's not that one. It's
Sorry.
Let me check the 412. It might have gotten renamed, so I'm going to go back to the other build.
Yeah, it should be right under that menu.
To clarify, we do have 2 different builds that we're working off of here, so some things might be in one and not the other.
Yeah, so I think that got renamed Zabir because the other build was the old McLaren build. So this is the official
Okay.
412 build now. So notice here under, this is the static mesh viewer, which is what you get by double clicking a static mesh in the content browser. You go to LOD 0 build settings and check high precision tangent basis. And that will give you infinitely better, or nearly, to where you're going to be able to have a really high polygon mesh and have very smooth normals. And the next option that Zabir added for us was custom resolution for sky and cube maps, and that's something that's been plaguing people who want to do ArchViz type stuff for a long time, is that cube maps have been limited to about 512 resolution per face. So now if you go under project settings, rendering, and remember I told you guys we'd be here a lot today, we go down to
It's actually, I think, right under textures.
under textures.
There's textures.
Oh.
The third option.
Okay, so right now this is the default reflection capture resolution at 128. You can boost that up to 512.
1024, I think. Yeah, at 1024, you will probably be using about 30 megs or so per reflection probe. So we didn't want to allow you to go any higher than that. If your project is really needs it, and you can obviously go into the source and bump that up to 2048 or even higher. But at 2048, you're looking at about almost 130 megs per reflection probe. So they can get expensive. The default used to be 128. So going to 1024, you'll get a much better quality reflections.
Awesome.
All right, so don't quite go there yet. Got it.
And then you can also override this on a skylight. So here I have selected the skylight in this level, and I've gone to the details panel under light, and you'll notice here is a cube map resolution. And I guess that's just Zabir so that you can tweak that independently of the global project settings, so you can have one special high-res cube map. Is that right?
Right, exactly. And so what we realized is that the skylight usually in scenes were treated differently than the reflection probes themselves. And so we wanted to make one setting kind of for all the reflection probes, and then one separate setting for the particular skylight. Usually you'll have one skylight and a bunch of reflection probes, and so that's kind of where we allow you to control the resolutions independently.
Right. And then the next one, which is kind of in a similar vein, is for a while we've had a reflection capture system in the engine where you go around and you place these spherical cubes, which I've just dragged one in, and it's taking a second.
Cube.
Or sorry, it's a sphere reflection capture, and you can now override to specify a cube map. Whereas traditionally, what this would do is you place it in the level, and it captures the actual level, and uses that as a reflection. You now have the ability to override that, and you could say, rather than capturing the scene, I could say, use this cube map. Let me see. If you set it to specify cube map, it'll take a second to load. Did you have something?
Yeah, we were originally planning on doing, we didn't actually end up using this for the GDC demo, but we were playing around with the idea of
I think you're cutting out there a little bit,
You're
Zabir.
cutting out a little. Try again.
So we didn't end up using the feature on the GDC demo, but we wanted to enable. So when we were prototyping, we thought we might want some artistic control over exactly what the environment was reflecting. So we added the feature. This allows you to kind of mock up a scene, take a cube map capture, and then use that as your reflection capture instead of what the scene actually has. So you can definitely go ahead and make like more complicated geometry or paint in other details that you wanted.
Okay, and the next one that I had for Zabir was the high precision G buffer normal encoding. And this is something that you might notice if you just look at a mirror reflection on a sphere, is that you'll see these tiny facets. And that's actually because we're running into the precision limit of the actual G buffer. So if you go down again, once again, to project settings, rendering settings, under optimizations, so that should be toward the bottom. There it is. So G buffer format, default, if you set this to high precision, you will actually, I believe it stores it as an octahedron under the hood, and you'll fix all those little facets that you see in a sphere. And you can actually test that out with, I think you'll have to restart the editor after changing that, isn't that right, Zabir?
No, it should just update right away.
Okay, so it's like changing the G buffer format, okay.
Mm-hmm.
Let me see if you can actually see. See if you can actually see the facets. It might be a little bit hard to see on here.
Yeah, I think you need to go to GBuffer. I think the formats we use are GBuffer format 1 and GBuffer format 3.
Yeah, I don't think the artifact is showing up here, but oh well. Just wanted to see if I could show it. Let me find the. I think that's pretty much it for the stuff between me and Zabir. So I guess we can go ahead and hand it off to Jeremy Ernst, who's going to go over some of the rigging and animation stuff he did, which there's about 1 million parts, so I'm pretty interested to see how he was able to wrap his head around that. So go ahead and pass the keyboard over to Mr. Ernst.
Awesome.
Alrighty.
Okay.
I'm really interested in using the. You said you can like replace the cube reflection, and all I can think now is put in a horrifying image. So it's like, oh, this is cool, and then you get close and you look at the reflection, and there's like a face right there or something. really
Yeah,
good.
you could
Yeah,
certainly
if you wanted to do
leverage
like a
it.
horror game, that's actually a really good use for it.
Cool. So, yeah, the McLaren team, the enterprise team, asked me probably about 3 weeks before GDC if I could come on and rig the McLaren, because initially it was going to be a static demo, just having the car there and showing the rendering features. And then they wanted to see, it'd be so much cooler if we could actually have it move and have it drive in and have it function, because that's something that really hasn't been done in a lot of these types of real-time enterprise demos before. So there was a couple of interesting challenges with this, and I'm going to go through them here. So the first is that the McLaren was CAD files from McLaren themselves, and I had never worked with a CAD file before, but basically it's every nut, bolt, screw, washer, every single piece of that car exists as a 3D object to a ridiculous degree. Just opening these files and getting them into Maya to even begin rigging would take a long time. Like it was a lot of work. I definitely underestimated the amount of work this thing. So originally I was like, rigging a car, that's easy, no problem. And then I actually saw what the work was, and I was like, oh, okay. So the first thing I did is when I got the CAD files into Maya, I group all the meshes up just for organization. And that model is about 13 million tries, I believe, something around there. And the little bullet point there says group the meshes by which bones they will follow. So what that actually means is the biggest challenge of rigging this car was that it could not be a skeletal mesh. It had to be a static mesh, but that doesn't really compute when you're talking about rigging. So what I ended up doing was creating a skeletal mesh that was just all the bones and a little static plane at the bottom so that I could actually import it as a scale mesh. And then each part of the car I would export out as a static mesh and attach it to a bone on that skull mesh. So we're not actually animating the car per se, we're actually transforming it by attaching it to a bone that's animating, which is pretty wild. So what this means is that there's no skinning, there's no skin weighting. Definitely not a normal way of going about this, but there was a few reasons why we did, and I'll go over those as well. So this is just kind of a little showing the outliner of our joint hierarchy. So the tire bone, for example, the left tire backbone, would have an animation joint, and then it would have an attachment joint, because all static meshes would import with their pivots at the origin. So I couldn't just attach them to a bone, I had to attach them to a bone that had the same pivot as the static mesh. So basically every bone, say you have a door bone over here, it's got a child bone that's at the origin, the door attaches to that, and this is what's animating it. So pretty unconventional, but it worked really well. So as I said before, there was no skinning. All these meshes are exported as static meshes. So originally this was a technical limitation due to the distance field ambient occlusion feature that was added. It didn't work on static meshes or skeletal meshes at the time. I'm not sure if it does yet or not. But there's actually a lot more benefits to doing it this way. If you were to try to import, which I initially did, the entire car as one scale mesh, importing 13 million triangles as one mesh and having it do the optimization stuff that it does on import was taking, I didn't even let it finish. After about like 4 hours of letting it sit, I just killed it. So one benefit is that by importing it as like 70 or so pieces, the importing was way faster. Also, we get LOD management. When you have the entire car as a scale mesh, you can LOD the entire thing. But when you have a car that's made up of 70 pieces, you can LOD out each individual piece depending on what you're seeing. And you can also cull things as well, which you couldn't really do with the scale mesh. So there are actually a ton of benefits to going this way. But it was definitely, I talked to a bunch of people at GDC that were interested in doing this type of enterprise work or do this enterprise work. And this is one of the major questions: is how do you get the thing to animate? And so, basically, static meshes attaching to a skeleton. So really, at the end of the day, we have, for the animation side of this, we have the car skeleton asset, the SK car, and the animation blueprint. Now the car itself, the SK car asset, that's just all the bones and then like a mesh that's weighted so I can actually import it into the engine as a scale mesh. And of course we have all of our static mesh parts. So in our blueprint, we have a list of all of our static mesh components there on the left. And then basically you go into each one and you tell it which bone it's attaching to. Now all these static meshes lie under our SK car scale mesh component, which you can kind of see at the very top left of the outliner there. So they're all children, all the static mesh components are children of the car, the scale mesh. And then that gives them access to the parent socket bone, so I can attach the correct piece to the correct bone. Another challenge is that when you're doing mechanical animations in a demo like this, obviously you want them to all be additive so that you can open one door, open the other door, and not have it reset the animation every time you try to do something new. The other thing that we learned, because we don't really do mechanical animations very much in our games, is that you really want to set all the montage blending to 0, because you really need the precision and you don't want it interpolating in between animations. I'm pretty sure I have a slide on that as well. And then this goes into a little bit about just the animation blueprints. So we utilize slots to animate different parts of the car at the same time. So I would go into the slot manager, create slots for the door, the hoods, both driver side, passenger side door, the oil door. And then, as you can see, the graph is very simple. It's just applying an additive, getting an additive identity pose, and then piping that into the final result. So I think this kind of goes over just using slots inside of animation montages. So I'm sure there's tons of documentation on our website about this stuff. But this is kind of just the process of going through and creating these animations for the car. Is creating new slots, assigning that section to a slot, and then making sure you set your blend times to 0 so that you get the mechanical animation you want. You don't get any blending. Because what we would see, especially because of our unique joint structure where we have a tire joint here and then the child is way over at the origin, what you would get when you'd have blending is that this tire would now wobble off because its pivot that it's animating from is actually way far away from where the tire is actually attached to. So to get rid of the wobbling artifacts, we'd have to set those blend times to 0. And then in the actual blueprint of the car, the one that we put in the level that does all the interactions and stuff, all we would do is just get the anim instance of the skeleton mesh component and then just play a montage on that anim instance. And we'd hook that up to some kind of interaction, whether it be the button push or whatever it was. So that was kind of a quick overview, and I'm sure we can make these slides available.
Oh, that's not a problem. Yeah, I can put them online.
So we can do that, but that's kind of the quick overview of that. I've got some. You know where those files are? The GIFs I sent.
This is what you sent me.
No, I updated it.
Oh, okay.
That's all right.
Then you can open up my mail probably. But yeah.
Oh, sorry.
Oh,
not over there.
Yeah, don't open up my mail on the main screen. That'd be kind of.
Let's see what dark secrets Alexander had.
Yeah,
I
it's
stay away
great.
from the computer when Jeremy's in charge.
It's like a bunch of It's like a bunch of 412 release postmortem notes probably more than anything. You can just type in your name up there and then get your stuff. But no, I don't think that you're Harris Jr. There you go. But yeah, it's a pretty fascinating whole setup of systems. It's not like I don't think. Actually, part of me kind of wonders, could you take this rig and then set it up on a different model entirely, or try to reparent it on something?
You maybe could. I mean, the pivots of the animated doors and stuff are very specific to that model of car. But if you were working with like not such an exotic car, like maybe more of like your normal cars that share chassis amongst the different models, you could probably do that for sure.
Yeah. Okay, well, I mean, at least there's that. Someone in chat was joking about trying to use this rig as like a character, like a person, try to get them to like walk up and use that same rig, and how everywhere it would be.
So there was actually, because it was a AutoCAD file, like I said, every single piece was in this thing. I'm trying to actually figure out how suspension works. I'm not much of a car aficionado, so when it comes to this complicated stuff, I was just like, actually had to do a bunch of research. But this is all static meshes just moving with bone, so it's not, there's no skinning here, which in that one you don't really notice anyway. But in this one, what you're seeing on this piece here is actually just scaling of the bone. So instead of like skinning this hose, it's just
It's just
using joint scale, non-uniform scale to achieve the effect. And again, each little piece here is all static meshes.
Yeah, they were wondering in chat how much data is actually in the CAD files that we got, and how high poly or how many tries these
Well, I know,
have.
I'm pretty sure Min did a stream on this, on the reduction stuff. I don't know what the original source was, but just the reduction that he did, the files I got back were 13 million tries. What they were initially, I think, was probably something absurd. I don't even think you could open the CAD file and like rotate around it. It was so heavy.
Oh my gosh.
But I mean, these tires, you don't even see it here, but the little hairs, like the little rubber threads are all.
It's the first mile things. My family used to own an does own an auto
yeah,
maintenance
those
shop.
are in the
are all
file. And they're actually in the editor too. We didn't get rid of those.
Yeah, you can barely see through the wireframe on this stuff before it gets optimized.
Oh,
so
yeah,
I don't think you can. It's like solid.
It's pretty impressive. But yeah, these are just some GIFs showing the different mechanics and all that kind of stuff.
I can see like the little hairs on this one really well. It's funny.
Oh yeah,
They get crazy. Look at the engine, the detail.
Oh, the engine is absurd.
I'm sure it's just.
And we didn't want to get rid of any of that internal stuff, even if you didn't see it, because in the demo you could do wipes and show certain parts of the car. So we wanted to make sure that everything was still there. But yeah, it was pretty nuts because you end up with a ton of pieces, because anything that needs to move has to be its own static mesh so that you can attach it to the proper bone. So, but like I said, there was a lot of benefits doing that way. Like you can LOD things out, you can occlusion coal, you can do a bunch of. It's just faster to import. Importing this one little tube takes just a couple seconds, whereas importing the entire car, I don't even know. I gave up. This was in the demo, but you could kind of explode the car and put it back together. So that was some of the stuff. And again, that's just bones coming off. I thought I had an image at some point of this skeleton, but I guess I do not, because it was actually pretty. It looks like an abstract piece of art. Actually, if you have the project.
I mean, yeah. It should
Which
be,
one is it?
The first one.
Okay.
Yeah, that's the 412 one. Right?
And then if you just go to file, the main level should be there if you need that.
I was just going to go to the car. This is the McLaren project?
Yes.
Okay.
Yeah, so it would have also probably been a lot more difficult to do the car customization if it was a skeletal mesh, I'm guessing, too, because you couldn't have had the individual elements
swapping
just swappable.
out. Yeah, so I guess that's the other bonus, is that you could swap out the roof, you could swap out the side view mirrors and stuff, and the wheels.
Spoiler, there's a lot of things.
Yeah, and so by setting them as static mesh components, you can still do all that logic, and it's just attaching to the parent bone that you had set up in the blueprint.
Yeah, I can't even imagine how we would have done that as a skeletal mesh. It probably would require a lot more work.
So yeah, you can actually see the abstract art that is this skeleton. It's pretty fun to look at. So what you're seeing here is just a preview attachment meshes. Building mesh distance.
Building a distance field, that's not good. That means it hasn't been loaded, this particular asset.
Oh, there you go.
So basically, it almost kind of creates the chassis of the car in a way, the way it looks, because each bone has to go back to this origin point where the static mesh pivots are. So actually, if I attach pull up the skeleton tree and swing it over here.
Wow.
So those are all the bones in the hierarchy, and most of those are just duplicates or children, so that we can actually attach the static mesh. But if I just look for the back,
And not every piece had a bone, right? Some of them were just shared to a same.
correct?
So,
yeah.
so there's even way more pieces than that to scare you guys even more.
So like back L tire attach, for example. We add a preview mesh.
Now, we did get a question about. I see the rim sitting there, and I was wondering, are the tires a separate mesh to the body, or is it merged also?
They are a separate mesh, actually, as I was just about to
Oh,
Yep.
show them here.
that answers.
That reminds me, we even used the vertex shader on the tires to give them that slight bulge where they contact the ground, because that was one thing that people noticed when they saw it, who were more enterprise division. They were like, why is there no weight on the tires? It's a fun little polish bit at the end.
Yeah. Yeah, and so here I'm just trying to add a preview mesh of the back tire to the car.
But look, more distance fields. You wanted that, right?
Yeah, of course. And then what you can get from that is like if I just play the, I think I called it intro. Oh, guess it wasn't intro. Try.
You looking for the roll-up animation?
Yeah. Let's see. Thought it was called intro.
Try roll.
Intro. There it was.
Oh, weird.
Okay. So what you'll notice is that with the bone view, these are the back tires. So those are the back tire attach bones that are spinning like that because they're pivoting around this back tire pivot, but yet the bone is way up there. And that's why if you had any blending on this, any blending at all, this whole tire would just wobble like crazy because it wasn't staying exactly in place. So pretty weird challenge. It was not so much, I mean, like rigging the car wasn't super hard. It was just figuring out how to get it in engine with the constraints that we had. I think it turned out pretty awesome.
Yeah, I really love how the back tire was figured out using this bone that's rotating. It's kind of one of those like silly behind the scenes things. It's kind of ingenious and it's kind of thing.
Like you don't really want to show it because it's ugly, but at the same time it's like, we figured it out.
Yeah, it's showing how the sausage is made. You know, you never want it to, but when you actually see it, it's kind of fascinating. That this is what actually goes into it sometimes. Yeah.
I think my favorite bit was the suspension. I didn't even realize at the time how much detail went into just the motion of those pieces. So you're saying you had to go and figure out how that was meant to move and just try a bunch of things found what interpenetrated and knew it was wrong.
I asked Francois a lot about what I was like, how is this? Because he has him and Min both know the car very, very well. They went to the factories and they talked with McLaren quite a bit, so they knew everything. And so anytime I was like, what does this thing do? And they're like, oh, it's supposed to do this. Oh, okay, that's cool. So that was pretty awesome. Yeah, those guys knew their stuff.
Cool.
Yeah, cool. All right, so we just have a couple of questions today. Let's see. You had said you created the Sparkle normal map in the engine itself, and in a previous stream we've talked about this, but they're asking how do you make textures within the engine, and I thought you used different software to create textures, and yeah, you can use the engine to create them, and you can use external software to create them. And I'm trying to remember what was the exact stream we had discussed that on, because
maybe Bullet Train, maybe before that.
I think it was
Kite Demo, perhaps.
I think it was Bullet Train.
It's come up a few times over the past few months.
Yeah. If you want to find out more about it, I think you could probably look up like Ryan Bruck's Unreal Engine stream, and there's a few of them in the past because you've been on a few times. But there's one, and I think it's the Bullet Train one that will explain that one to you and how to do it. So
there's also a couple of videos on YouTube if you just search for. Render to texture physics drop, perhaps.
And
I have a couple of YouTube videos under my name that you could find. Basically, it's a render to texture blueprint that you tell it what mesh to drop and how many, and just wait for it to finish and take a screenshot is the gist of it.
Yeah.
But yeah, feel free to post or email us with questions, and I can try to put that up on the forums.
Yeah, and another thing, I won't do the full reveal because it's for 4.13 and I don't want to steal anyone's thunder, but there's another feature coming that makes it a much more streamlined to be able to render out textures and things like that. So stay tuned for 4.13.
Oh, awesome! Yeah, we'll have to have Mike Fricker come on and talk about it when it's more finalized and down the pipeline. But that's excellent because I would love to. Yeah, I'd love for that to be an easy process because I know a lot of people ask us for features that kind of lean us into like not engine territory, but content creation territory for an engine. But it's nice to have a couple little tools in there for very fast iterations and all that. So that's nice. Good to hear. All right. What is the performance impact of changing the G buffer precision to high precision?
Originally we had prototyped with storing the normals using octahedron mapping, and we were storing that in 32 bits per pixel. We ended up shipping with 16 bits per pixel, and it turned out that though the 32 bits per pixel was a little bit faster, it led to a lot of problems in like actually daily use. It caused us to generate a whole lot more because we had to have a specialized version. So the 16 bits per channel, it is more expensive, certainly, than just having 32 bits per pixel, so it's now 64 bits per pixel. It's just mainly going to be memory bandwidth is what you're going to be paying for it. So it's not prohibitively expensive, but it's not free.
All right.
Yeah.
That's a good way to put it.
Yeah, the other side of it is that also with the approach that we actually ended up shipping, it's also available on mobile. And so if you do have like a high-end mobile phone, like especially like what we ran the Protostar demo on, that's definitely a phone that can also take advantage of that feature. So it's not so expensive that we can't run it on mobile even. It's just not as cheap as what already exists. Yeah.
All right. That works. Let's see. Question for Zabir from Pizzarita. Are there any plans? To occasionally? Sorry, a little water went down the wrong pipe. Are there any plans for occlusion culling of dense meshes such as the car? If so, what are the possible approaches that would be tried?
Yeah, so that was an interesting challenge that we had in this project even, right? Like, normally your scene does have, 5 to 6 million polygons, but everything here is just concentrated on a single asset. So right now we were fortunate enough that it was just a demo that we were setting up in we can control the hardware, and so we kind of were just able to throw faster hardware at it. But ideally, we would like to, so if I were to guess, we would try to set up maybe some sort of occlusion culling system that's within the car itself. So you could subdivide into like a KD tree or a quad tree of some sort within a actual array of static meshes, and so that you could cull out little pieces inside. So essentially the same thing that happens in a wide scene, but set it up more localized to the actual highly dense car itself. Yeah, I don't know if that's exactly the answering the question. Could you? Well, yeah, I don't know if there's any other details they wanted.
That was the entirety of the question. But,
okay.
Yeah, it's about.
Yeah, so there's nothing inherently. We didn't end up doing any extra work.
Oh wait, hang on.
You're cutting out.
Yeah, you're cutting out. Try that again.
So, yeah, we didn't do any additional work for the occlusion culling on this vehicle than what was already in engine. But if that's something that a lot of enterprise users start to use, yeah, we may look into building a localized KD tree on the object itself to do further culling.
All right, cool. Let's see here. Last question for everybody. Did you guys get to sit in the McLaren at all? Because I didn't.
I didn't either. Mark Ray got to drive it, but he already has like 3. So.
Well,
No, I did not. I didn't get to make that trip, but did get to go look around the inside of Mark Rain's car. That's about it. So,
so I'm guessing Min probably got to.
There's video with Min, Zach, the audio, Zach Bellica, and Francois all at the McLaren factories and stuff, being in the car and shutting the door over and over to get the sounds and like rolling the windows up over and over to get the sounds and all that. But
okay.
But at the show itself, I don't think they let anybody sit in that car.
No, not at the actual show. I just wasn't sure if at any point in time you're like, for the development of it, they're like, yeah, just come sit in one for a bit or something. But yeah,
I don't think they would have had a problem. I think the guys that we met from McLaren were super, super cool. They were really, really nice. Mark Roberts, I believe his name was. Super, super nice guy. But I think it was like on loan from a local dealership, and
Yep.
so like the
So
dealership
they
was
had
like,
to have
you
like a
have
security
to
guy out there.
have, yeah, 2
and-
security guys
and
at all
watching it.
time, 24
Yeah.
hours a day.
Yeah, that was pretty interesting. Yeah, and Chris is in the chat. He was also at GDC, and when we were pulling it out, apparently it almost ran him over because he was there for it because he was hanging out. But sorry about that, Chris. But yeah, cool. Thanks, guys. Let's see here. Yeah, that's about it. So for next week's training stream, we're going to be. Oh, Ian has posted up what it is. It's going to be Wes Bunn talking about new sequencer features. I know we had talked about having some stuff with characters and importing them. We're going to try to get something scheduled down the line for that so we can actually have a proper talk about it. But he's actually got something prepared for sequencer. We'll be talking about that on Tuesday. We'll see you all then. Make sure to send me your team information if you're going to be in the June game jam. It'd be really awesome to just go ahead and have everyone pre-register and have your information up. But that's all I got for today. Thank you guys so much for coming on. Thank you, Zabir, for calling in. And thank you, Francois, who is currently somewhere else. But yeah, thanks everyone. And thanks for coming out. See y'all next time.
Thanks, guys.
Thanks.